Greetings, South High Packers. Welcome to another round of Algebra 3-4. Let's go ahead and get started today with a new concept, graphing radical functions. And to graph radical functions, we need to go ahead and start off with just a general equation, and here it is, y equals the square root of x. Now, because there's no number outside the square root, we're going to call this a parent function. It's just a parent, y equals square root of x. There's no numbers on the outside. So what we need to do is we need to make a fancy table of values. So let's go ahead and make a table of values. Now to start off with our table of values, our xy table, we need to go ahead and figure out what numbers would be good to replace this x. What can I substitute into x? What nice numbers can I substitute into x so that I can square root? Now you guys all know your square roots. We can do the square root of 1, we can do the square root of 4, the square root of 9, square root of 16, 25, 36, 49, and so on and so forth. So let's just use our first couple of good solid square roots. We can square root 0, we can square root 1, square root 4, and square root 9. So that's going to be my x values. Square root of 0, 1, 4, and 9. My first four numbers, and those are my x. If I take 0 and I substitute it into x, the square root of 0 is 0. So my y value would be 0. If I take 1 and I substitute it into x, the square root of 1 is 1. If I take 4 and substitute it into x, the square root of 4 is 2. And 9, the square root of 9 is 3. So here's my table of values, xy table. Now I want you to recall from a previous unit that you cannot square root a negative number. For example, if I change x to -4, the square root of -4 can't do it. It turns out to be an imaginary number. So I'm going to ask you guys to write down that little sentence there. It's pretty important. Square root values can never be negative. So again, these x values, they won't be negative. They're only 0 and positive. Now if you take these and you graph them on a coordinate plane, 0, 0, 1, 1, 4, 2, 9, and 3. If you graph them on a coordinate plane, let's move over here. This is what your graph is going to look like. 0, 0, 1, 1, 4, 2, and all the way over here is 9, 3. You can look, when I connect my 4 points, it's a little bit of a curve. And so if I look at this graph, my graph only occurs on the positive side of the x-axis. So my domain, which if you recall, domain means x values, my domain is x such that x is greater than or equal to 0. These 3 points are all greater than or equal to 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 are all on this graph. But -1, which is right here, and -2, which is right here, is not on the graph. So my domain are all x values that are greater than 0, greater than or equal to 0. And my range, if you recall, range means y. Here's 0. The graph is above the 0. So my range is all y values greater than or equal to 0. Domain is x, range is y. And there we have it. There's the basic idea of graphing radical functions. Next section, we will talk about graphing radical functions when we have numbers on the inside and outside of the square root. Thanks for hanging out with Will and I today. You guys have a great afternoon.
Go Packers!